Hello everyone. So, in this video, I'm going to show the current development nodes I created using the Hunyuan video diffusion model to generate videos by using an image as a guide passed through these custom nodes. I call it the HunyuanVideoImageGuider. Why am I calling it that? Well, as everyone knows, the text-to-video model weights for Hunyuan Video aren't built to use an image as an input for latent space rendering. So, what we can do to use an image-to-video method with the current Hunyuan Video text-to-video model is to use the VAE encode and pass that latent image along with the text prompts as a guide. This is because in diffusion transformer models, we mostly use the basic guide in ComfyUI to guide each image frame displayed in the output videos. Therefore, the output won't look exactly the same as the input image. And as you can see right here, I've got a Christmas-themed image, and my output video has a similar style but doesn't look exactly the same. You can think of this like the IPAdapter we used back in Stable Diffusion 1.5 and SDXL, where you use an image as a reference and pass it to the diffusion model for processing the video. I've also added some settings here. We can move the range on the X and Y axes, zoom in and out, and of course pass in the number of frames. I call this the frame num. Then I resize the image here as well. So we don't need multiple nodes for resizing the image, passing it into the image input, and doing more duplication steps. Instead, it's all in one node. I'm setting the target width and height just like a normal resize node that we usually use. I was inspired by the resize image node from KJ node, which has similar features. For example, you can crop the center of the image if it's too large and focus on the ratios and display area in the center. You can do that here as well, and it won't affect the aspect ratio of your image in the output display. The resize mode also allows you to keep the ratio or follow a custom input. When I choose the custom input, it uses the width and height that you input below in these two parameters. And of course, that's what we'll get in the output videos, the output aspect ratio and dimensions. It's pretty easy and self-explanatory. You don't need to install additional Python libraries. I've already published this node on the GitHub project page, where you can download it right now. I'll provide the link in the description below. There's also a workflow examples folder where I've included the demo workflow for this setup. That's the same workflow I posted in this screenshot and the same workflow I'm currently showing in the ComfyUI interface here. So there are some tricks we have to keep in mind when using this image as a reference guide. Well, it's not going to be image to video because if you've used image to video before, you'll know that the first frames of the video will follow exactly the same image we input. For example, in Clean AI, we have an input image, and that's what's called image to video. A lot of people have a misconception about this. They think, oh, the AI video models are going to have both features for text to video and image to video. But actually, if you dig into the technical details, you'll notice that the model weights for Hunyuan video are created for text to video only. For image to video, hopefully, they'll release that soon. A lot of people have asked about this. For real image to video, like Clean AI, what we're showing here is that the image I input as the reference image for the first frame and the coherence and consistency of the diffusion transformer AI video model are able to maintain these styles starting from the first frame and then generate further action movements, like in this demo video I created. That's the difference between text to video and image to video in basic terms. So, for this image guider, it's only bringing the latent data of an image as a reference and passing that to the base latent image for sampling. Through the basic guide, we're able to influence how the diffusion transformer model generates the image frames. But of course, there are a lot of settings you'll need to adjust to achieve similar performance or maintain similarity with your input image. I've tested this, and this is a very basic workflow for Hunyuan video, without text input prompts and without text encoding. This is just a basic text-to-video workflow. But when we add the VAE latent encode and pass the latent image, it's not the same as using an empty latent image. That's the difference. Even though the text-to-video model weights for Hunyuan video are what we currently have, we're still able to use the latent image data as an influence to guide how the video is generated in the output result. Therefore, we have to set the denoise as the most important part here. I've set and tested some variables during my testing over the weekend while creating this custom node. I've found that a denoise setting between 0.7 and 0.9 allows the character to move a little better. The movement, of course, is in low resolution for this example because I set a very low resolution for the target width and height. If you want high quality, you can set it to 720p resolution, which will match the output of the Hunyuan video model weights. For higher detail in the resolution, you have the tile size, which you can set to something like 512. That would be ideal. For the sampling steps, I've tested that along with the denoise. I set the sampling steps to 20, which doesn't produce too much motion for this image guider method. When I set the sampling steps to 25 or 30, we start seeing some movement and motion from the character or the objects around it. We're seeing some motion in there, which is pretty good already for an image guider. And this is like a little hack for how we can use an image for this purpose. You can treat it like an IP adapter to play around with. Let's try some results here. When I set the zoom to 0.15, it's a very slight zoom in. As you can see in the output video effect here, I've also documented some settings in the parameter inputs for the move range X and Y. The X and Y settings here range from -1 to +1. In that range, the movement of the image frames will move up, down, left, and right. But there's a problem I'm currently facing, which I'll show later. There's a black border on the side when the image moves. The zooming effect, however, is working pretty well in this version. I've set a very small range for the zooming effect here, starting from 0 to 0.5 in the zoom effect settings. What you can do here is set the maximum zooming effect to 0.5, which is good enough. Too much zooming variance in the calculations can cause the image to zoom really fast and suddenly focus on something small, like a cup in the background. I don't prefer too much zooming, just a slight zoom like 0.1 or 0.15 is good enough. And if you set it back to 0, there will be no zooming. It'll just show the image staying still with the same aspect ratio, and then that will only animate the objects in the video. So that's how we can run this. Also, the frame numbers here determine the length of your video. It's the same concept as what we usually work with in the Hunyuan video text-to-video workflow, so there's not much to change about that. In this demo, let's try something with each setting here. First, let's use another image. For example, like this image I have here. Let's say I want the girl to look very similar to this theme, where she'll turn around and walk in a hallway. For this kind of motion, I'd suggest using more frame numbers to allow the AI to animate it properly. So I'd set it to at least 69 frames for these animations. For the scheduling here, I'll set the denoise to around 0.8 or 0.85. Last time, I tried this image with the same prompt and settings, but used a denoise of 0.8, and it didn't animate too much movement. Well, it depends. Different images will have different effects, so we'll have to test this kind of thing. Let's say the denoise is 0.8. Of course, the character's face won't look exactly the same, but the overall image elements will be injected into our video. So let's run this and try it. Again, if you've played around with IPAdapter in Stable Diffusion, you'll know what I'm talking about. How the similarity of an image is passed into the output result. It's just like what we do nowadays with Flux Redux, which follows the same concept. Okay, so we've got the result here, and it looks very similar overall to the image in terms of style. And yeah, again, you can treat this like the IP adapter we used back in Stable Diffusion. This time, it looks pretty nice. We've got some animation of the character, where she's turning her head and starting to walk. Of course, if I set the number of frames longer, she'd start walking with more motion as the video continues. So far, we can animate this just using the image guider, and you can see it looks okay. At least we're taking some big steps toward creating a look-alike image-to-video model by using custom nodes like this, passing the latent data to try a little hack for AI videos to make the output image similar. Of course, for the face, it won't be the same because the core of the video generation comes from the text-to-video model weights. We can't influence it like we see in Clean AI, where the first frame is used as the input. That's because text-to-video and image-to-video model weights are two completely different things. They're two different mechanisms. Image-to-video brings the whole image into the latent space and then generates each latent noise from there, moving the objects or characters in the image. But in this case, using the image as a guide, it's not the same process. This is more like the IP adapter we've played around with before. So we need vision language models to provide text prompts for the details, descriptions, and everything about the image. That's why I'm currently using Florence 2 as the vision model to align with that. With the help of this, we're able to maintain consistency in the styles. I've also used the string combine node to add another input strength here. So whatever I want to animate in this reference image, I can just prompt it simply like, she should turn around and walk in the hallway. That will create some animation for the character, showing how it'll animate in the output video. We pass all the strength into the clip text encode, which is just the normal practical way of using text to video. That's the same thing. We don't need to change other custom nodes. Here, I've mostly designed this custom node to work with and be compatible with native ComfyUI nodes. As you can see, I'm using the native load VAE, dual clip loader, and other sampler guidance nodes that come from native ComfyUI nodes. So yeah, we can try some other examples as well. Let's save this video first. It looks pretty nice. I've also brought up another example, which is this Christmas girl. The output of this, which I tested in the previous video, is what I got here. Let's try this image again with different settings. We've tested higher denoise numbers, but if you set the denoise to 1, it'll make the output image or video totally different from the input image. So, my sweet spot here, let me make a note for you guys, is a range of 0.7 to 0.9. That's the good range for this method of guiding the image. If you go higher or lower, it won't have a good effect. For example, if I set it to 0.5, it won't animate the image or any objects in the output result. For demo purposes, let's set this to 24 frames, which will be about 1 second of animation. And let's try this without any camera movement first. Here, we've got the generated result, and this time it's very similar to the input image. As you can see here, it's very similar. We've got the same pose as well. Of course, the face isn't recovered, but you can use other custom nodes to recover the face, like the face detailer in the reactor node package, or simply do a face swap for the source video or source image. In this case, let's check out how that goes. We've got this little animation of the hand waving. This comes from my text prompt. She is waving hands and cheerful. That's very accurate to what I wanted for the actions here. So we've got the animation going, and we've also got some fire burning in the fireplace. It looks good this time. The combination of the output video looks, well, not exactly the same, but almost. We can't say it's exactly the same, but it's most likely referencing the likeness of the input image, because this time we've got a high likeness of the output video by using 0.5 denoise, but, as you can see, the animations of the hands, body, and background fire aren't moving much because the denoise is low. Therefore, there won't be much movement in this video. If you want more movement, like the character waving their hand in bigger motions or the flames in the fireplace moving more, you'll need to set the denoise back to something like 0.8. That's the sweet spot for animations here. So, let's say I'm setting it to 0.8, and we'll see how the result turns out differently. We've got the generated result here, and let's bring it back side by side for comparison. That'll make it easier to see. Look at this. We've got two totally different outputs this time because the higher denoise number affects the generated video a lot. The composition of the output video isn't going to be the same as the input image. And that's another use case. Sometimes you don't want the exact same look and feel as the input image. In that case, you can use a higher denoise number. But with a higher denoise setting, you can animate the motions and movements you instruct in the text prompts to be bigger. Right now, we're dealing with a video model, not an image model, so there's more to consider than with the IPAdapter. With the IPAdapter, we were only considering the composition, coloration, and likeness of the image. But now, we also need to consider the animations of the objects or characters we're animating. Again, the higher the denoise, the more it eliminates the static nature of the image used as a guide. This way, as you can see, I'm using the hand-waving text prompt here as the custom input. Whatever you input here for animations will be affected by the denoise setting, just like in the previous example where the hand movement was very subtle, not too much. But now, you can see the hand movement involves the whole arm, and even the outfit and background have less likeness compared to what we got with the 0.5 denoise setting. So, this is something you'll have to test depending on the style or output you want to achieve. You can experiment with these settings to get the result you're looking for. So if you don't like the output likeness being too different, you'll need to lower the denoise. But for motion, the good range I've noted here is 0.7 to 0.9. That'll make the animation movements a lot more noticeable. So let's go back to 0.7 and see how that looks. Okay, so once we've generated with 0.7, you can see the composition of the output video. We've got the fireplace and the Christmas tree back, and the placement and pose of the character are sitting like this with the legs laying down on the floor. Yeah, so there you have the difference between different settings here. If you need to use this, you'll have to test with whatever numbers you want to input. Now, let's talk about the other settings in the node. We've already tested the zoom in the first example, and now we'll test the move range X and Y. This is something that's not perfect, and I'm not entirely happy with how the X and Y movement works currently. Maybe I'll do another update later to fix the issues. I'll show you why I don't like the X and Y movement. Okay, so in this example, let's say I have this stock image here. I've prompted it with, he feels surprised and his eyes look up. That'll be the animation of the character. I've set the X to 0.5, just not too much movement for the camera panning left and right. Since we only have a static image here and the text-to-video model can't move the canvas along with different angles, we're only able to manipulate the objects within the image. So when we move the X and Y, we'll see black borders on the sides. I'll show you what that looks like. I think I'll either fix this, or if the effect isn't good, I'll remove the X and Y camera panning and just keep the zoom in and zoom out features. Okay, so we've got the generated result. Obviously, the character's face isn't going to be the same because, well, text to image or text to video, as I've mentioned before, doesn't preserve exact likeness. For the movement, I tend not to set the X or Y too high. Y moves up and down, and X moves left and right. You guys can test whichever direction you want to play around with. But if I set this too high, let's say I'm not going to use 0.5 here, I'll use 0.3. That's already a lot of movement. For X and Y radius movement, once you go over 0.3, you'll start seeing the black borders on the sides, which you'll see in the next result. So here's the generated result. As you can see, when I set it too high, you'll see the black borders around the image which are outside the canvas. You can think of this as the canvas of an image. Basically, the mechanism pans the positions of the image within the canvas, moving it left or right. But we need additional latent image data to fill up these black areas. The problem is, we're already using the latent image data to inject the noise, the latent noise of this image. So, this is the trade-off of the text-to-video model. If we were using an image-to-video model, the AI would inherently understand the latent image, and we wouldn't need a guide for the X and Y radius. Instead, we could just use a text prompt to tell the AI to do the camera panning. But right now, since we're injecting the latent image, the AI only understands the image frames here. These frames are moving left or right in this example, so don't set the movement too high or you'll get weird black borders. I'd say the maximum should be 0.05. That's the most ideal range for how much you can move the image in the result. Let's say this time I'm moving the Y-axis so it'll move up. Let's check it out. Okay, so we've got the result here, and actually, using 0.05, just a very little bit of movement of the canvas from the image frames, we're able to do the camera pan up. But you won't see anything too obvious, and there are no black borders in this setting. So let's say, I think I'll put the suggested settings in the GitHub project page as well because this is the range, but ideally, I'll also mark it down in the description. And for the chop size, ideally you'll follow the width and height recommendations for Hunyuan video. That'll work just fine. So so far this is how the whole thing works. Again, these custom nodes are already published on GitHub. How I built this was based on my understanding of AI diffusion models and reading through how guidance works, especially the flux guidance nodes and how they pass into the sampler custom nodes. There's coding in the GitHub project where ComfyUI uses the guider as the guidance to manipulate the image frames. I put that together using DeepSeek Copilot, and I also used bolt.new. Actually, I need to highlight this too. It's a pretty nice tool. Based on whatever ideas I have, I can change some code using Copilot. Of course, it's going to be a bit of trial and error because they don't have ComfyUI in the runtime here. So, the only thing I can do is modify the Python code. I've got some other examples I've been testing. As you can see, there are some other Python files here that I tried out, doing some trial and error, and this is the result so far with these custom nodes. So that's the custom node I built for fun and to give it a try. This guy looks obviously like a nerd, and it's pretty funny. You guys can give it a try animate any image, but don't treat this as an image-to-video method. You can think of this like the IPAdapter. That'll make it easier to understand how it works. So, that's it for this video, and I'll see you guys in the next one. Have a nice day. See ya.